Everyone, I'm Prasanna Reddy Pulukurti from Rochester Institute of Technology. Today I'll be presenting X-CoT, an explainable text-to-video retrieval framework that brings LLM-based chain of thought reasoning into retrieval systems. Our goal is to make these systems transparent, interpretable, and trustworthy so we can understand why a video was retrieved rather than just what was retrieved. The motivation for this work comes from a limitation in the current text-to-video retrieval systems. Most existing methods rely on embedding models and cosine similarity to rank videos. While effective in performance, they behave as black boxes lacking interpretability. These systems are also sensitive to low-quality text-video pairs, which makes debugging and improvement difficult. We want a retrieval system that can both explain its reasoning and highlight data issues when they exist. CoT introduces a reasoning-driven retrieval framework that uses large language models to make the reasoning process explainable and transparent. We also expand existing benchmarks by adding structured video annotations that capture objects, actions, scenes, and summaries, allowing the model to reason over richer semantic information. Given a text query, all the candidate videos are compared pairwise through LLM chain of thought reasoning, and their results are combined using Bradley-Terry model to produce both the final ranked list and natural language explanations. X-CoT achieves consistent performance gains across multiple benchmarks and provides detailed rationales that help analyze both the model behavior and data quality. To obtain high-quality structured video annotations, we first use a multimodal large language model to generate detailed frame-level captions. These frame-level captions are then aggregated and passed through an LLM, which produces a final structured annotations describing the objects, actions, scenes, and overall summary of the video. Additional post-processing refines grammar and consistency, and the final structured annotations are stored in a JSON format. These structured annotations form the semantic foundation for the reasoning steps in X-CoT. The retrieval process in X-CoT starts with an embedding model, such as clip or xpool, to obtain the top K candidate videos for a given text query. We then perform pairwise LLM comparisons between candidates and the query. Each comparison yields two outputs: a decision on which video better matches the query, and a short textual explanation supporting that decision. We aggregate these pairwise outcomes using Bradley-Terry model, which refines the ranking mathematically, and we further combine all the text rationales into a final explanation summary using another LLM pass. This gives us both improved ranking and interpretable justifications. We evaluate X-CoT on four major benchmark datasets using three different embedding models. Across all settings, X-CoT achieves consistent gains, such as a 5.6% improvement in recall at 1 on MSVD with clip. Beyond numbers, the key strength is explainability. The system generates human-readable rationales describing why one video ranks above another and highlights any potential caption noise or mismatch. An example: for the query, a man grabs at snakes and throws them around the room. The baseline model Xpool incorrectly selected video A. X-CoT, on the other hand, correctly ranked video B at the top because its reasoning explicitly mentioned a man throwing snakes, the key semantic detail missed by the embedding model. This demonstrates how X-CoT captures fine-grained semantics and provides natural language justification for its rankings. Beyond improving retrieval, X-CoT also helps diagnose data quality. For instance, in this example, the video caption mentions a stop sign, but there is no stop sign in the actual video. By surfacing such mismatches, X-CoT helps detecting noisy or misleading captions, which is valuable for cleaning and refining benchmark datasets. To conclude, X-CoT unifies accurate retrieval and reasoning into a single framework. It improves both accuracy and interpretability, while also allowing us to identify noisy captions and understand model behavior more clearly. Since X-CoT follows a plug-and-play design, it can be easily integrated with the different embedding models. Overall, it brings us one step closer to trustworthy and transparent video retrieval systems. Thank you so much for your attention. You can explore more on our project page, access the paper on archive, browse the code on GitHub, and view the annotated dataset on Hugging Face.